Hello students, welcome back to my class. Hope you are all fine. Today I am going to start a new chapter from class 10 mathematics, polynomial. In class 9 we have learned about this topic. A polynomial is an algebraic expression in which the power of the variable is non-negative integer. That is, if the power of the variable is 0 or 1 or 2 or any positive integer, then it is known as polynomial. But if the power is fraction or negative, then it is not known as polynomial. Let me show you with the help of example. So here is the definition of polynomial. A polynomial is an algebraic expression in which the power of the variable is a non-negative integer. For example, 3x square minus 2x plus 1. Here the power of the variable x is non-zero integer, non-negative integers. Like here power of x is 2, here power of x is 1, here power of x is 0. So these are all non-negative integers. Similarly, y cube minus y, this is also a polynomial because the power of the variable is non-negative integer. Now consider one or two more example. Here 7 root over x minus 2, this is not a polynomial. Similarly, 2 by y plus y square minus 1, this is also not a polynomial. Why this is not a polynomial? Because we all know root over x means x to the power half. So since the power of the variable is a fraction, so it is not a polynomial. Similarly, 2 by y is equals to 2y to the power minus 1. Here the power of the variable y is negative. So this is also not a polynomial. So thus an algebraic expression is known as polynomial only when the power of the variable will be non-negative integers. A polynomial in x, a polynomial in which the variable is x, is known as polynomial in x. If the variable is y, then it is known as polynomial in y. If the variable is z, then it is known as polynomial in z. Note that a polynomial is always represented as p and in the bracket the name of the variable which is there in the polynomial. Since x is there, so that is why in the bracket it is x, and it is known as polynomial in x, polynomial in y, polynomial in z, and so on. We can put any variable. Now consider a polynomial px equals to x square minus 3x minus 4. If we put x equals to 1, so we will get p1 equals to 1 square minus 3 multiplied by 1 minus 4. So that will give us minus 6. So here minus 6 is the value of the polynomial at x equals to 1, because when we are putting x equals to 1, we are getting p1 as minus 6. Now if we put x equals to 0, then p0 equals to 0 square minus 3 multiplied by 0 minus 4. So here you will get minus 4. So minus 4 is the value of the polynomial at x equals to 0. So in this way, by replacing x by any real value, we can get the value of the polynomial. Similarly, if you put x equals to 5, then p5 will be 5 square minus 3 into 5 minus 4. So that will give 25 minus 15 minus 4 is minus 19, 6. So here 6 is the value of the polynomial at x equals to 5. Hope you are getting it. Now see what happens if I put x equals to minus 1. So p minus 1 will be minus 1 square minus 3 into minus 1 minus 4. So that will give us 1 minus, sorry, it will be plus minus 4, that is 4 minus 4 is 0. Similarly, if we put x equals to 4, then p4 is equals to 4 square minus 3 into 4 minus 4. So 16 minus 16, 0. So here there are two values of x. When the polynomial, the value of the polynomial becomes 0. That is, when we are putting x equals to minus 1, the value of the polynomial is becoming 0. Similarly, when we are putting x equals to 4, the value of the polynomial also becomes 0. So this minus 1 and 4 is known as the 0 of the polynomial x square minus 3x minus 4. Means if we put any real value of x in the polynomial, x or y or z in the polynomial, and the value becomes 0, then we will say that that real value is the 0 of the polynomial. So if we put any real value k and we get pk equals to 0, then we will say that k is the 0 of px. Let me show you. So if we put x, a real value k, a real value k in a polynomial such that pk equals to 0, then k is called the 0 of px. If the polynomial is in x, then k is called the 0 of px. Understood the meaning of 0 of px? Good. Now in a polynomial, the number of zeros depends on the degree of the polynomial. If it is linear polynomial, that is, if the degree is 1, then the polynomial will have only 1 0. If it is quadratic polynomial, that is, if the degree is 2, then the polynomial will have 2 zeros. If it is cubic polynomial, that is, the degree is 3, then the polynomial will have 3 zeros. For example, if px is equals to x plus 5, then there is only one value of x where we will get px equals to 0, that is x equals to minus 5. So if we put x equals to minus 5, then it will become minus 5 plus 5 equals to 0. So since it is linear polynomial, the degree is 1, so there is only 1 0, that is minus 5 is the 0 of px. Similarly, if px equals to, let me see this, show you this one, x square minus 3x minus 4. Here in two cases we have got the value as 0, that is minus 1 and plus 4. So since it is quadratic polynomial, so there are 2 zeros. Similarly, let us take one cubic polynomial, y cube minus y. Say if we put y equal to 0, then p0 will become 0. If we put y equals to 1, see 1 cube minus 1 is also 0. So 1 is also the 0 of py. And if we put y equals to minus 1, then also the value of the polynomial will become 0. So in this cubic polynomial, there are 3 zeros, 0, 1 and minus 1. if you put the value of y as 0, 1 and minus 1, the value of the polynomial will become 0. So there are 3, 1. Now graphical representation of a polynomial. So see here, the y-axis and the x-axis, a polynomial is y equals to x plus 1. I have plotted the value of x and obtain a graph line like this. So this is the way to represent any polynomial, linear polynomial rather. Since the polynomial is linear, so we are getting a straight line. Note that this linear graph is intersecting the x-axis at only one place, so that is this polynomial has 1 0. So without going for algebraic solution, we can simply plot the polynomial in a graph and number of time the polynomial the graph line intersecting the x-axis, that will give us the number of zeros. This is a quadratic polynomial. So when the value of x and y are plotted in the graph, we are getting a parabola. Either it is open outward, either it will be in the form of open outward, or it will be open downward. So this quadratic polynomial, if it is plotted in the graph paper, we will find that either it is an open upward or it will be open downward. So sometimes, like in this case, the graph line is intersecting the x-axis twice, one here and the other here. So this gives the number of zeros. Since it is intersecting the x-axis twice, so number of zeros is 2. In algebraic simplification also we have got that this quadratic polynomial, sorry, y square will not there, this algebraic polynomial has 2 zeros, and that is proved in the graphical representation. Similarly, if we go for a cubic polynomial like py is equals to x cube minus x, then we will obtain a graph like this. Let me show you. We will obtain a graph like this. So here the graph is intersecting the x-axis thrice, means this polynomial has 3 zeros. So in this way we can obtain the number of zeros graphically without going for algebraic simplification. Simply we plot the values of x and y in the graph and we will get a curve which will give us how many zeros are there by intersecting the x-axis. We will count how many times it is intersecting the x-axis, and that will give us the number of zeros. So hope you have understood this part, how many zeros are there in a polynomial, and that can be found either by algebraic simplification or by graphical representation. So that's all for today. Hope you can do some more sums by yourself. Till then, bye. Meet in the next class.